Okay, in this lecture, we'd like to solve some examples to see how we can make use of the diode in different electric circuits and how to make use of the models that we just developed. So the first example will look like as follows. So example, let's say 1. Let's have the following circuit. I have a circuit with this diode and connected to a certain resistance, 1 kilo ohm. This is silicon diode and this is 5 volts. This is straightforward, assuming that there is no internal resistance given to us. This means that this will be represented as what we said. It's nothing but a 5 volts and then a battery, because we said it looks like a closed switch, and then a resistance, and this will be the threshold voltage, which is 0.7 volts. This is 1 kilo ohms, and therefore I can just easily calculate what will be the current ID. It's nothing but ID will be 5 minus 0.7 divided by 1000 ohms, and this is equal to 4, if you wish, 0.3 milliamperes. Okay, now how about if I have the same circuit but the voltage is 0.5 volts? So what do you think will be the current ID? This is again 1 kilo ohm, and again this is silicon diode. We know that since this voltage here is less than the 0.7 that should be here, then in this case I know that there will be an open switch, and I have this one here, and therefore no current will be flowing. So we'll say that ID in this case is equal to what? Is equal to 0. Okay, now let's have one more case where we have the voltage or the circuit looks like this. Now this is another example. Example 2, let's say. Now this is the circuit. I have this is the voltage. Okay. The same as we have before, plus and minus. And here I have the diode connected this way, yeah. Now what will be the current ID? I know that in this case I will not have any current because simply the diode is reverse biased. You can see that in this case the voltage, let me just draw here and with a different color of the pen, we know that the voltage at this point now is plus, let's say this is 5 volts, so this is 5 and this is the 0, so this will be much higher than this one, and therefore the diode will be reverse biased. And in this case the circuit representation will look like, again, there is an open switch. This is the switch, and there will be of course a voltage here, and there will be no current. So ID here is also equal to 0. Let's have one more example. And in this example, let's say one more example, example number 3. I have this circuit. I have 2 silicon diodes that are connected in series, so both are SI. Okay, so this is silicon and this is silicon, and they are all both connected to a resistance of 1000 ohms. And again, what will be, as an example, the voltage at this point here? What is V output? You can see that if this is 5 volts, then we can represent this as what? We say that this can be represented as, this is my voltage source. I have 2 batteries that represents the thresholds, and then this will be 1000 ohms. And of course this is 0.7 volt, this is 0.7 volts, and if I would like to calculate what will be the current ID, if this is 5 volts, ID will be simply what? 5 minus 0.7 minus 0.7 divided by 1000, and that will be 3.6 milliamperes. So how about the voltage V output? V output will be 3.6 times 10 to minus 3 multiplied by 1000, which is equal to 3.6 volts, which is very logical, as we know that the voltage at this point here will be nothing but the voltage here minus the voltage drop across those two. Okay, let's have one more example, and we say that it's a new example here, example 4, where I have two diodes connected in series, but one is silicon and the other one is germanium. So this is germanium, and they are connected in the same way to 1 kilo ohm resistance. So we said that in this case the representation should be again the same. I have plus minus. This is 5 volts, as we said, 5 volts. Here I have threshold, and here I have another one, but notice that this will be 0.3 volts, this will be 0.7 volts, and then you have your 1 kilo ohm here. And in this case we can say that the current ID will be what? ID will be equal to 5 minus 0.7 minus 0.3 divided by 1000 ohms, and that will give you 4 milliamperes. Now we can have some more cases, a little bit more complicated. As an example, let's have the following example. The example says, I have a new example number 5. It says we have the following circuit. Look at it. I have a resistor here, I have a diode, and I will assume that this is again silicon diode, and I have a resistor here, and I have a voltage at this point equal to minus 5 volts. And I would like you to calculate, if this is the voltage here, 10 volts, this resistance is 4 kilo ohms, and this resistance is 3 kilo ohms. We are requesting you to calculate what is the output voltage here, V output, what will be the voltage here, V1, and what will be the voltage here, V2. And of course we are expecting to calculate what is the current here, which is I diode. So in order to solve this problem, it's not difficult at all. The whole issue is that you have to be careful. You can represent it again as follows. So what we have resistor, we have this threshold voltage, and then you have this resistor here, and then you have a minus 5 volts here. Now notice that this is 0.7 volts, this is 10 volts, this is 4 kilo ohms, and this is the 3 kilo ohms. So I can tell, if I would like to see what is the current that will be flowing, it should be flowing this way. It's clear that this is plus and this is minus, and therefore from here I can say that since this is minus, this will be somehow here, this is positive and this is negative, and therefore I expect that the diode will be forward biased. So you can see here there will be a current, I will call it I if you wish here, and definitely it will be ID, the same current here and here, because this is an open circuit here. I'm just looking for the output voltage, so there is no current flowing in this portion here. So what will be the voltage? According to, if you wish, Kirchhoff voltage law, we can say that it's easy. I can say that the current I will be equal to the voltage here, which is 10 volts, minus the 0.7 minus the voltage here, which is minus 0.5, sorry, minus 5, divided by the resistance, which is equal to what? 4,000 plus 3,000. And if you calculate this one, you will be able to find that the current is 2.04 milliamperes. So if somebody would like to say, okay, what is the voltage at this point here? Okay, what is the voltage at this point? That's easy. It's 10 minus 0.7, which is equal to how much? It's equal to 9.3 volts. But be careful now. What is the voltage that is I'm sorry, that's wrong, because I have a certain voltage drop here. No, I'm sorry. So the voltage here we can calculate in a minute, because this will be our output voltage. But first we can calculate what is the voltage V1 here. If I calculate V1 here, I can calculate the voltage here. So first we can calculate V1. So what is V1? V1 is nothing but the 4,000 ohms multiplied by the current, which is 2.04 milliamperes. And if you calculate, this is 8.16 volts. What is the voltage V2? That will be again 3 kilo ohms multiplied by 2.4 times 10 to minus 3, and that gives me 6.12 volts. So if this voltage here is 6.12, then what is V output? I can say that V output is equal to the voltage V2 minus the 5 volts, and therefore it will be equal to what? It will be 6.12 minus 5, which is 1.12 volts. So these are some examples. We can get another example here, which is showing us what if the diodes are, as an example, in parallel. We can have some diodes in parallel, we can have some diodes in different cases. So hopefully in the next lectures we'll be able to see some more configurations of the diodes.